Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to predict water solubility. So let's get into this. So a large part in predicting the solubility of a substance in water is going to be using the rule of like dissolves like. And what does that mean? That means that anything, how should I put this? Um, that is referring to the similarity in the attractive forces between the particles. So if you have a nonpolar substance, nonpolar substances are more likely to dissolve in other nonpolar substances. Same with polar substances. If you have polar substances, those are more likely to dissolve and will dissolve in polar substances. So like dissolves like similarity in the structure, similarity in the polarity of the molecules means that you're going to have similarity in their attractive forces and therefore their ability to mix together with each other and dissolve within each other. So that's what the rule is kind of getting at. So if we can identify what kind of substance we have and whether it's polar or whether it's made up of ions or nonpolar, we can then determine whether it's going to be soluble in water. So keep in mind now, so if we're looking at water, water is made up of H2O, and so therefore it is a polar molecule, right? So if we write this down up here, so we have H2O, and so it's got polarity because the polarity in the bonds, the difference in electronegativity indicates that therefore you have a polarity in the bonds. The oxygen is much more electronegative. It's going to attract the electrons towards this side. So it's going to be a partial negative side and then the partial positive side. So water is polar. And so therefore you would expect it to dissolve polar substances and ionic substances because ionic substances have ions that have charges, and so you would expect them to be dissolved as well. So let's go over the samples that we have and determine is it more likely to dissolve in water or not. So for number one, we have nickel 2 chloride, NiCl. That is an ionic substance that is made up of positive ion, negative ions. And so in this case, we would expect the ionic substance to dissolve in water. The ions would be attracted to the water molecules. The water molecules will pull apart the different charged ions, and and then so they would dissolve. Now, that's not true for all salts. So there are a lot of salts that don't dissolve in water, but nickel chloride is not one of them. Chlorides will dissolve in water. So A, we would predict would be soluble in water, right? Barring any other things that we need to keep in mind. So B, so we would say ionic, so it's going to be soluble. We would identify that as soluble. Okay. B, we have 2-propanol. Remember, the OL ending indicates it's an alcohol, which means that it has an OH group, and the OH group is called a hydroxyl group. And so here we have it in the formula here. That lends polarity to the molecule. So without the OH group, we would just have carbon and hydrogen. Carbon and hydrogen bonded together. Those are non-polar bonds. So it would be a non-polar molecule. But now that we have the OH group in here, that adds polarity to the molecule. And so therefore, this would be a polar molecule. So we're going to write polar molecule. And so we would expect this to be soluble in water because water is polar and like dissolves like. Polar dissolves polar. For C, we have 1-pentene. 1-pentene is this formula here. You can see that this is indeed all carbon and hydrogen. So nothing else is involved here. So no polarity in the bonds. So this is a nonpolar molecule. So nonpolar molecule. And so we would predict that this would be insoluble, not soluble in water. Next, we have CS. It's nonpolar. If we write the Lewis dot structure for this, so you would see, I'll write it here. So you have the S double bonded to the carbon, double bonded to the S. The sulfur has two lone pairs. And so you can see that this is going to be a linear molecule with sulfur on both sides. And so the polarity in the bonds, whatever polarity is in the bonds, that's going to cancel out, leaving you no polarity in the molecule. So you have symmetry. So the symmetry destroys the polarity. And so the overall, well, it destroys the polarity in the bond. Well, the polarity is still in the bonds, but because of the symmetry, they cancel out. So the overall, the polarity of the molecule is zero. So no polarity. So this is a nonpolar molecule. So nonpolar molecule. And so we would expect that to be, again, insoluble in water. Next, we have propionic acid. So here we have this CO2H. That is a common group called a carboxylic acid group. So that is a very polar group. So it looks like this. If I draw the Lewis dot structure, it would look like this. So I have hydrogen, 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 and then I have carbon with two hydrogens here. And then I have this third carbon, and then that carbon has a double bonded O with an OH. So right away, you can see that anytime you have ionic acid or ionic acid, this kind of ending, that tells you you have a carboxylic acid. So that would be this group here. So anytime you have a COOH or CO2H or something that looks like this, that indicates that you have what is called a carboxylic acid. And so this is going to be very polar. And also you have a hydrogen bonded to oxygen here. So that's going to allow for hydrogen bonding. Water also has hydrogen bonding. So that's another way in which the water and this group are alike. So we would expect, given the rule that like dissolves like, that this is going to be soluble in water. So again, this is a molecule. I'll write it here. So this is a polar molecule, I guess. We'll say polar. So polar molecule, and we would expect it to be soluble in water. So soluble in water. Next, we have sodium fluoride. So just like the nickel 2 chloride, sodium fluoride is an ionic compound. We have a metal and a nonmetal. So we would expect that to be soluble. So this is ionic and therefore soluble. And again, there are salts that are not soluble, but this is not one of them. We have fluoride with this halogen. We have a group 1 metal. Those are always soluble in water. So this ionic substance is going to be soluble in water. Acetic acid. Again, acetic acid, we have this ic acid here, just like we have ic acid here. So if I underline that, that indicates that you have a carboxylic acid again. So here again, we have the CO2H group. And so that indicates that we have, again, a molecular substance. If I draw the Lewis dot structure out again, I have a C, so H, 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 and then we have a C, double bond O, O, H again. So we have that group. So very polar. So this is a polar molecule. Also, again, we have the H bonded to the O. That's going to be hydrogen bonding. Water, again, has hydrogen bonding. So again, we'll predict that this is soluble. So polar molecule. And we predict it's soluble in water. Acetylene. Acetylene is only C2H2. So again, no polar bonds here. So therefore, this is a non-polar molecule. So we'll write that down. So non-polar, oops, let me write that better. Non-polar molecule. And we would predict that that's insoluble in water, since water is polar. So polar and non-polar are not going to mix very well because their attractive forces are different. And methanol, here we have methanol. Again, OL, we have the OH group, we have an alcohol. So the oxygen here allows for the polarity also. I think I forgot to mention up here, the OH, we have hydrogen bonded to oxygen. So that allows for hydrogen bonding. So again, similar to the attractive forces of water, which also has hydrogen bonding. So like dissolves like. So we would expect this to also be soluble. So we have a polar molecule, and so we would expect it to be soluble in water. And let me put H bonding here too, because that's also important. So we have H bonding here, H bonding. And so that, ladies and gentlemen, is how you predict whether something is soluble in water or not. So I hope you enjoyed this video. If this was helpful in any way, then please like the video, share the video, hit that like button. Also, make sure you subscribe to my channel, hit that notification bell. And when you do, make sure you click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you would like me to help you with, please put it down below. If you have a topic you want me to cover, put it down below. I would love to do that for you. Thanks for joining me and have a great day.